they could try to instead inject what's called the closed shadow DOM. Okay.
Oh, the shadow DOM.
Yeah.
Did they do that from? They did that from the isolated world, right?
Yeah, they did it from the isolated world.
Sup, y'all. If you've listened to Critical Thinking for any time at all, you know that we very often cover the Asset Note team's research that they put out on enterprise security and 0 days that they've been popping left and right. And lucky for us, now the team no longer just has a blog, but they've got a podcast called Surfacing Security, where they talk about everything enterprise security related and attack surface management related. And I've been following each episode, and just listen to these episode titles, okay? Internet-wide recon, moving past IP-centric approaches, very interesting. Beyond shadow IT, understanding the true attack surface of your software. This one's focused on like third-party softwares and how they can affect your enterprise security posture. And the unknown complexities of DNS resolution. Guys, these guys know DNS resolution like no one I've ever met. I've probably spent 10 plus hours just discussing DNS resolution and their DNS pipeline with the Asset Note team, and they know their shit inside, outside, upside down. So if any of those sound interesting to you, check out the new Surfacing Security podcast on the Asset Note YouTube channel or wherever you get your podcasts. All right, back to the show. Alrighty, dude, we're rolling. Matan, welcome back, man.
Good to be back.
Dude,
very excited for this one. We have a banger episode coming up.
We really do, man. And we have not a lot of things on the docket, which means we can go deep into them. only 3 topics, one of which is browser extensions, which I feel is
somehow we got to 6 pages.
we did get to 6 pages, so we'll see if we get through all of it. But I think browser extensions are kind of a really underserved attack surface in bug bounty, and I think that because you told me that.
Yeah, I've been kind of capitalizing on it, but I think I'm gonna have more competition after this episode, you know?
Yeah, dude. Thanks for agreeing to do it, because I know when we were talking about prepping for this episode, you were like, maybe we'll push this episode out a little bit. Maybe I should milk this a little bit more.
I thought I stopped milking it, but then in preparation for this episode, I took another look at some of the extensions I tried to hack, and I still found some bugs in there. So yeah, definitely stuff to find.
Okay, so I'm gonna say that this one is a browser extension hacking version 1, because I know there are some things that you've discovered recently that you haven't fully had the time to develop, and we're not gonna drop them completely yet. But maybe we can get those someday. That would be cool. Yeah. All right. Let's get into it, man. Browser extensions. I guess the first thing that we need to understand is what is the structure of these browser extensions, and what is the threat model.
Before we get into that, I just want to say that this episode might be a little hard to follow, especially in audio form, you know, just because it's gonna be unfamiliar to a lot of people, and the structure of a browser extension can be a little complicated. You really have to visualize it, which might be a little tough. So don't worry if you don't get it the first time. I think you can just learn from experience, you know, messing with an extension is gonna teach you a lot about how extensions are built, way more than I can sort of explain via audio. But anyways, the way extensions are built, first of all, just in general, we all know what extensions are, but their purpose can be either to extend the functionality of a set of sites, can be one site, multiple sites, or all sites, or of the browser itself, right? You can maybe change the theme of the browser or something like that. And in order to do that, if you sort of think about it, a lot of the time, extensions need to have sort of a way to run code in the site that they want to extend, right? And on top of that, they need some sort of thing that coordinates all of this, you know, because you can have like many tabs of the same site. Say you're trying to extend youtube.com and you have like multiple scripts, it can get kind of messy. You need something to coordinate all of it. So the browser developers sort of build like an extension component for each one of these roles. So in order to execute code in the sites that you're trying to extend, say it's like all sites. One example that I had for like a simple extension that we can sort of keep in mind while we're talking about it is an extension that I will call like save my JPEGs, okay? And it's just gonna add a save button to every image on the page. So every image element in every page it's just gonna add a save button that will save it to some site. So in order to do that, we will need to inject some JS code into every site that's open in the victim's browser.
You're already thinking browser. About it from the attacker's perspective. I think that's gold. It's funny you say that because that's literally how I talk all the time with this.
I'm autocorrecting constantly. So we're gonna need to inject code into every page in the potential victim's browser. Now, the sort of component that does that in browser extensions, it's called the content script. So you can have many content scripts in the browser extension, and they can be injected in a few different ways. It gets a little complicated. But basically what you'll see in like most cases is the sort of config file of the extension, which is like a JSON file. It will just have like the content scripts that will be injected and a list of like which sites it will inject to. And actually, before we continue, it's important to note that the sort of structure and behavior is a bit different between the last version of extensions called Manifest v3. You might have heard of it because there was some noise about it.
Yeah.
And Manifest v2, right? And because Chrome is going in the direction of Manifest v3 and all of the big companies have already updated, I chose to focus just on Manifest v3. So that's what we're going to talk about. So anyways, when we want to make like the Save My JPEGs extension, we're gonna have all of the content scripts, each injected into a different tab or iframe or whatever. Like every page that renders, we're gonna have a content script in it. Now, we need like something to coordinate all of it. So sort of the brains of the extension, the like main script that runs and coordinates everything, that has like the capability to inject content scripts and stuff like that. It used to be called the background script. Now it's called the service worker, which is very like
that changed.
Confusing.
Okay, that makes sense now because I was like, I heard both of those terminologies and I was like, I don't see where this fits into the structure, but they're actually just the same thing.
So it's very confusing calling it the service worker.
Yeah.
And it actually has some differences between it and like a regular service worker.
Right.
So I'm not sure why they picked that term. Anyways, it's called the service worker and it sort of runs in the background and coordinates everything, right? So there's a little graphic here that you have. And
yeah, I'll show it.
Yeah, it's taken from Space Raccoon's blog actually about browser extension hacking, which was pretty great. You can read it after the episode. But the little diagram isn't totally complete because you can see if you're looking at the pod on YouTube, there's sort of like a section about the web page DOM, which is sort of the site that is getting extended, basically. And it has like a content script, in this case, a few content scripts that were injected by the extension. And it has like the original JS code that's running inside the site. And what Space Raccoon chose to highlight here is that those two can communicate via post message.
I've got the Space Raccoon plushie right here, man. So, ready to go. Let's go.
Those two scripts can communicate via post message, but they can also communicate via other channels, like custom events, stuff like that. We're going to get into it a bit further. Then that content script can communicate with the background script, the service worker, via a browser API called the message passing API. There's a bunch of functions that are pretty similar to post message, and that's just how they communicate. So that's the basic structure. You can add some stuff on top of that. Like some extensions will have like another script that runs inside the actual context of the web page. But we're gonna get into that a little bit further.
Yeah. So let me try to summarize this really quick, because there is a pretty complex structure here. Okay, we have three main component, or two main components that you've mentioned so far. Well, if we can count manifest.json, it'll be three, right? So we've got the content script, right, which is the script that the extension injects into the DOM of the actual page that the user is on. So depending on the configuration file, this could be, any website. It could be a certain set of websites, maybe like star.ctbb.show or whatever, or it could be just one, specific website that it wants to modify. That's the content script. And that is sharing the DOM with the actual JS.
Yeah, so I'm actually
not sharing the content, the actual JS environment, right?
Well, was just gonna talk about it. So,
okay, all right, hit it.
Yeah. So basically, if you sort of take the structure that we explained so far, injecting a content script straight into the page and implement it, there's a bit of a problem that comes up that the sort of Chrome developers or browser developers in general had to solve. So imagine you have like a site and say it's malicious, and you inject that content script straight into the JS environment of that site, right? Now you want to give the content script a certain level of privilege, right? It has to have the ability to, say, communicate with the background script or read cookies from pages, stuff like that. Whatever permissions the extension has. But you don't want the regular environment of the site that you're injecting into, which can be malicious, and to have that same level of privilege. So you need to have some way of separating the two. And once you do that, you also have to make sure that these sort of environments can't mess with each other. Mainly that the malicious site can't mess with the content script. And because then it could manipulate it and somehow take advantage of the privileges it has.
And if you share that JS environment at all, you're just kind of opening up a can of worms, right? Like you because there's so many things you have to think of, from like prototype pollution and various variable hijacking or whatever. So they need to do something different. Yeah.
Anyone who's tried to create a JavaScript sandbox, like the one that used to be in AngularJS before they gave up, knows that it's a tough problem to solve.
Right.
There's a whole bunch of stuff that can go wrong there. So what the Chrome developers specifically chose to do, I think it works a little bit differently on Firefox, but I haven't looked at that, is they chose to make the code of the content script run in what's called an isolated world. So
such a cool name, though.
Yeah.
Such a cool name.
It's a badass name.
Yeah.
Like, I breached the isolated world today.
Oh my gosh, dude. That's like top tier hacker shit right there. If you breach the isolated world.
Yeah. So what the isolated world sort of does is it makes the content script still kind of runs in the page, because the extension has to have the ability to like modify the DOM, read the location, stuff like that. It has to sort of feel like it's in the page, but it sort of prevents the page from messing with the extension, in the sense that if the page like sets a global variable, say it overrides window.alert to be some bullshit function. Now that will like reflect in the actual context of the page that overrode it. But if you look at the isolated world, window.alert will remain the same. So you can't really influence that. There is a bit of a catch there, but I'm still milking it.
Oh my! I know what you're talking about.
Sorry about that.
It's a good one. I'm excited to release that in a little while.
In a while.
In a while. No rush. I'm not rushing you. I'm just saying.
Yeah.
It'll be a good one.
When I retire.
Yeah, sure.
At 19.
Yeah.
Anyways.
Yeah. In 2 years.
Yeah, in a few.
That's great.
Years.
Yeah.
Anyways, the isolated world is sort of there to prevent as we talked about, a malicious page from messing with the content script. But in some cases, extensions will want or have to run JS in the actual context of the page, in the actual world of the page.
Sure.
Say you want to make like a competitor extension to Franz Rosen's post message tracker, okay?
Right.
You need to override the sort of add event listener or I don't know, a window.onMessage setter, stuff like that.
Sure.
So that when a new post message listener gets added, you need to catch that. So in order to override it, if you try to override it in the content, in the isolated world, it won't affect the actual page. So you need to actually inject JS into the actual page and then override that sort of actual like add event listener.
Yeah. I think this gets tricky a little bit too. I was talking to Kevin Mizu, the author of DOMLogger++ about this, is, with that structure that the Chrome developers have put into place, you're having to either, append a script to the page or use, I think, one other route that there is to inject a script. Yeah. And that has a delay to it, right? It's not instantaneous. And so there are some events that won't get caught by DOMLogger++ for like the first like 20 milliseconds or whatever it is until it runs its overwrite script because of that delay.
The issue that DOMLogger++ is trying to solve is hard to solve with an extension. It's like a lot simpler than forking Chrome, but it's hard to solve with an extension. Yeah.
Forking Chrome,
anyway.
You're opening up a can of worms a little bit there if you do that. I mean, it would be really cool, and I would love to see somebody approach the problem, right, where you fork Chrome and somehow you keep it up to date and consistent with Chrome and you have a good amount of like updates and that sort of thing, but take out some of these things that hinder us to have introspection further into security. But it would be much easier if the Chrome devs just did this. So if anybody at Google is listening and you have an in at the Chrome team, let me know, because it would be really nice if we could just get a couple flags put into place that would allow us to overwrite things like document location or window location href and like get introspection into those specific attributes.
Yeah, there's that, and also if a reason to fork Chrome is right now, you can't sort of have a DOMLogger equivalent for testing browser extensions because DOMLogger as a browser extension doesn't have the privileges to mess with the JS of other extensions. So that would also be a reason.
Yeah. Okay. All right. So we can get back to the structure, but let me review for a second because we've covered a lot of ground. Okay. So we've got the manifest.json file. That's the configuration file for the extension, right?
Right.
And that defines a bunch of different things. Two of them are the content scripts, which get injected into the DOM of the page, but not in the same JS environment. They're in an isolated world, right? So if they want
not exactly into the DOM, but like into the page, but in a separate world.
They get injected into the page in a separate JS world and have access to the DOM. Is that accurate?
Yeah.
Okay. All right. Just glad we got that squared away there. Okay. So they're in the isolated world.
Sorry for being a little scattered here.
No. I need, this is exactly what we need to understand it thoroughly. And we can't hack it if we don't understand it thoroughly. So this is great. And actually the plus of that is that the content script can affect the DOM and affect the JS execution in the normal execution world, the non-isolated world, right. By injecting a script into the DOM, which would trigger the script.
There are a few ways to do that. So basically, right now we're talking about sort of a separate component of the of what an extension could look like.
Right.
So we have like the two very standard components, the content script and the background script or service worker, whatever you want to call it. But some extensions will need to have a separate component. We can call it like the injected script.
Yeah.
That's just how I saw it referred to in one of the extensions I've looked at. So the injected script, it has to be like a script that runs in the actual world of the page that is getting extended, right? So for the extensions that do need that functionality, which is not too many extensions, but it's pretty common, a few ways to do that would be either to add an actual script element to the DOM, which is what I think DOMLogger does and Post Message Tracker does. Or there are a bunch of native ways to do that in the actual Chrome, the Chrome APIs. So you have either you can set you can add another content script and set a special flag there to make sure that that script is injected into the actual world of the page, or you could use some other function. I forgot what's it called.
Yeah.
Anyways, there are a few ways to do that.
I think it's provide a certain option. Execution world, is that it when injecting the content script?
Yeah. Execution world main, I think.
Nice.
Okay.
Nice. Okay.
So
So you can
anyways,
define the world, the world that this thing is executing in. I like that. That's good.
So
dude, I don't know what it is about the world, but it just sounds so like anime, right? Like it's like in this world we'll be executing. Anyway, okay. So we've got that.
we need
Those
to
execution
isolate
worlds.
our world from all the attackers.
Exactly. So we've got the content script. It's the thing that's injecting into the page. We can define scripts for the actual JS execution world that's normal, right? So that's where a lot of the functionality is happening. But then also in the manifest JSON file, we also have the service worker, also known as the background script, that is not a part of, doesn't have access to the DOM, and is just sort of like a back-end process for the extension that can communicate with the content script.
Yeah. I'm not sure that it doesn't have, because I think there are a lot of weird ways to do stuff like directly from the background script, but usually what you'll see is like it will communicate with the content script, and the content script handles all of these tasks.
So we should probably think of the background script as like, or the service worker as like the back-end code of sorts for the extension versus the front-end code, which is the content script.
It's actually where you're supposed to implement the most sensitive functionality, because it's the part that is least exposed to the actual, like, to a malicious attacker. In the actual Chrome docs, they mentioned that you shouldn't trust any communication between the background script and the content script, because they assume the content script is compromised.
Really? Even in the isolated world? Even in the isolated world?
Yeah. It's theoretically, I can understand where they come from, but you can't actually implement that if you have a complicated extension. You're always gonna have some sensitive stuff in the content script.
Yeah. And I think in Spacer Coon's write up, he sort of mentions a scenario where essentially they're using post message to communicate from the JS environment on the page, the normal JS environment, to the content script, and that content script is then passing that message straight through pretty much to the background script via the send message API, right? And in that scenario, it's like, okay, well, sure, if you code up the content script in such a way that you're just arbitrarily passing JSON messages through,
you're sort of breaking a boundary.
Then you do sort of violate that trust boundary. I can see that. Yeah.
So anyways, I was going to talk about something a little similar to that. We mentioned the injected script component that an extension can have. Again, it's like not mandatory, it's optional. So the interesting thing is, if you look at the communication between that little component and the content script, because it can't access the background script directly. If you look at that communication and think about it a little, whatever that communication is, however they implemented it, it can be hijacked. And that's because the injected script, it's in the actual environment of the attacker. An attacker has like full control over it. However you're gonna try to interact with that content script, whether it's injected script, whether it's via post message or custom events or something like that, an attacker can imitate that like very easily. And you can't do like an origin check because they're gonna have the same origin.
Yeah, because it's the same JS and execution environment even. Yeah. Wow. Okay, so we've got that attack surface as well. You've got the attack surface of any scripts injected by the content script. You've got the content script attacking the content script itself, and then I guess trying to attack the backend script via proxy of sorts through the content script, as far as attack vectors go for these extensions.
Do you want to start getting into attack vectors?
Yeah, I mean, well, okay, let me just try to repeat back to you, and you can validate my understanding of the structure, okay? So we've got the manifest JSON. I know we've already done this a couple times.
I know, but it's very hard. That's why I had the disclaimer at the start.
Yeah, it gets complicated. Actually, I'm gonna go ahead and just share the screen again for those of you that are on YouTube, so you can see the graph, and then hopefully this will make a little bit more sense. Okay, so first we've got the manifest JSON file, which is not actually displayed in that graph. So let me scroll up. Here's something that kind of looks like the manifest JSON file, right? You're defining these content scripts. You define where they are. You describe a regex of sorts. It's not really a regex, but it's like a pattern on what pages these content scripts should be injected. And then now we've injected the content script. The content script is in the web page, but in an isolated world. Right? So it doesn't share a JS execution environment with the original JS on that web page. And the content script is able to inject scripts into the page and affect the JS execution environment of the web page, but the original JS does not have the ability to do the opposite of that, right? And like affect the content script because of the isolated world. And then the primary ways for these things to communicate is via post message. So the original JS can send a post message to the content script and vice versa. And then we also have this other component, which we consider sort of like the back end of the extension, which is the background script or the service worker, and the content script can communicate with the background script via the send message API. So that's it's kind of like post message, but for that back end to front end communication for the extensions. However, the front end JS, the original JS, cannot communicate to the background script directly using the send message API. So if you're trying to attack the background script, you kind of have to do that via proxy through the content script.
Exactly.
Did I get all that right?
Yeah.
All right. Can I get a round of applause for that, please? Just from you, Matan. Thank you. All right. Very good. Hey guys, our sponsor, Project Discovery, has dropped a new tool in collaboration with Google's own Mandiant team called TLD Finder. Okay, picture the sub finder, but for top-level domains. Need I say any more? Check it out. And I suppose I should probably give you a round of applause, well, for actually like explaining the thing. So
Trying
great job.
to.
No, it's great, man. All right. Okay. So now let's talk about how we can attack these Chrome extensions now that we sort of understand what they are and what the structure is. Okay.
Yeah. Okay. So I want to like do a few distinctions here between like different attack scenarios and attack surfaces. So I think the best attack scenario or like attack surface is the case where you have like the extension trying to extend a malicious page. So if it's like our Save My JPEGs extension, it will try to extend every page, add like buttons to it. So when the victim navigates to a malicious page, that's where you have that sort of attack scenario.
And is this the extension extending the page with a content script, or is it's injecting the script into it? Are we talking about the injected script, or are we talking about the content?
Just the content script.
Just the content script. Okay, sure.
And the injected script is sort of like a sub case of that.
Sure.
So when you have that content script in there, even though they have like an isolated world, it still opens it still opens a whole bunch of attack surface that isn't very standard and you might not think about. For example, because they share the DOM, the two worlds, they have like the bridge of the DOM, it's getting even more dramatic. If the extension injects something into the DOM, like in our example button, then from the attacker's JS code in that page, you could just like do button.click, right?
Right, because it's a part of that DOM. They're sharing the DOM.
Right. Or like if it injects a paragraph, you could just read the content of the paragraph.
Right? So let's say the extension makes a button on the page, and then the extension itself registers an event handler to that button event, like a click or something like that. Then okay. Sorry, I had to sneeze there for a second. but you're so then you can actually simulate that by actually just on the JS side clicking that button, which is the equivalent of executing the function in the content script because of the event handler. Is that accurate?
Yeah. There's a little caveat there because why wouldn't there be? Events have like a weird property. Like the actual event object that gets like sent to the event listener when an event happens. They have the is trusted property. And for click events, is trusted is only set to true if the click was actually done by the user.
Interesting. So that's sort of a defense in depth technique that they could use is check whether it's a trusted click or not.
But what you can do as an attacker, if you have just like the button there, you can mess with its style, make it full screen, stuff like that. Get creative, basically.
Sure.
But it prevents you from just going click, 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 click. And
that makes sense. But I think also, man, one of the crazy things to me about situations like this where you have control of CSS is how much we have programmed users to just click accept cookies or decline cookies, whatever you click, right? Like when you come to a page, do you even think about it anymore? Like, I just click reject,
but
okay, well, maybe I'm the sheep here, or whatever. But like, you're gonna harvest a click one way or the other, right? With that every single time, and then like maybe you make the button depress, go down and then come back up and then it doesn't go away. What are you gonna do? You're gonna click it again, And so I think we've programmed users to mindlessly click on something as soon as they go to the page, which, maybe it's a win for privacy because you have an opt-in or an opt-out for cookies, but it's definitely an L for user interaction required bugs.
it's not really an L because you could always just make a victim click somewhere on your site. It's like it's not supposed to be a security boundary.
Yeah, but is it so frictionless though? Like, maybe it's not. I don't know. Maybe that's my hot take. But I just think it's like it's almost like opening like I click a link and I don't even see that box and I still click it. Yeah.
So yeah. Anyways,
I'm sorry. Go ahead.
So when we talk about the case of a browser extension, specifically the content script, injecting UI into a malicious page, there are a bunch of ways to do that, right? So we just talked about injecting the elements directly, but if they are sort of aware of this attack scenario, they could sort of go around that a little bit. So they could try to instead inject what's called the closed shadow DOM. Okay.
Oh, the shadow DOM.
Yeah.
Did they do that they did that from the isolated world, right?
Yeah, they did it from the isolated world.
I'm sorry. I'm tripping today. Okay. So they're gonna put it in a closed shadow DOM.
A closed shadow DOM. Luckily, Masato Kinegawa, the GOAT, did some research on closed shadow DOMs, and I should explain what it is. A shadow DOM is sort of like another document inside the document. So the same way you have like an iframe, which is another document inside the document. But it's interesting because it sort of isolates what JavaScript can access a certain element. So say you have like JavaScript running in function A and JavaScript running in function B. function A can like create an element, add a closed shadow DOM to it, and then append that element, like add some content to that closed shadow DOM. And then when it appends that element to the DOM, attaches it, function B can't access the content of the closed shadow DOM.
Can function A though? Because I was under the impression that once. Oh, really? Okay, that's interesting. I was under the impression that once the shadow DOM hit the DOM, that it was sort of untouchable.
It's like I think the way it works, and I haven't done a lot of testing with it, but I think the way it works is the sort of you have like a reference to the variable when you created that.
Okay.
And
kind of like a message board of sorts.
Right. It's interesting that you mentioned a message board because maybe there are some tricks where you can like override a bunch of prototypes to try to get a handle to that original shadow DOM variable. Anyways,
very interesting.
In this case, we can do it because it's in the isolated world. Yeah,
that's great. Okay, so they're putting it in a shadow DOM.
Yeah, theoretically, if they put it in a shadow DOM, then you can't like mess with any styles, or maybe I think you can actually. So you can mess with styles, and you can like clickjack it, because you can overlay some UI on top of it. Now, what Masato did is some research. You actually covered it on the pod.
Yeah, dude, I freaking love it. It's amazing.
With font ligatures.
Yeah.
So you can use that research to leak content from that closed shadow DOM. So we have like three separate levels of vulnerability here. One is if they inject an element straight into the page, then you can do whatever you want with it. The second case is when they inject a closed shadow DOM or a shadow root. Then you can leak stuff from it, but it's sort of using a technique that I don't know how intended it is. You can leak stuff from it, and you can clickjack it, and I think mess with styles. Now, the fourth level is if they inject it in an iframe. Okay, so they have an iframe either to the extension's origin, which looks like Chrome-extension, / the extension's ID, and then some HTML page, or to just some site of the Chrome extension developer. So if they inject that into the page, then you can't mess with any styles or something because it's in an iframe, but you can still clickjack it. So whatever way you go, there's no really running away from the problem that UI that gets injected into a malicious page will always be clickjackable.
And that has impact in these scenarios because it is tied directly to the functionality that is defined in the content script, right? So, clickjacking a button that may not have any direct security impact isn't going to get you a bounty likely on these scripts. But if you can
don't just go reporting it right
away. I always just feel like I have to disclose that scenario. Like clickjacking gets a bad rap because people don't exploit it correctly. But if you I think you mentioned somewhere in the doc here, Matan, but
MetaMask.
MetaMask had like a 120K bug, right? That was pretty much clickjacking, right? Yeah. So it's like we gotta outline the full threat model, and then clickjacking can be a really, really serious bug, especially in this extension environment, right?
Right.
Yeah.
And we're actually gonna talk about the MetaMask bug a little more. The technical details are very interesting. There's a little caveat there that the MetaMask developers missed. It's fun.
Okay, let me repeat this back to you real quick. Okay, so we've got three levels of sort of attackability here. You've got if the content script injects some UI into the attacker controlled DOM directly, then we can click it, we can modify it, we can do whatever, and then when the thing actually gets clicked, then it will trigger something in the content script. And we can. There is some caveat to that with the trusted sort of thing, right? Whether the event is trusted or not. But we got some workarounds with that with clickjacking. And if we use the shadow DOM, then you can it's sort of like read but no write, right? Like you can leak the contents of what is injected into the shadow DOM, but you can't actually like you can't actually click it or trigger any events because it's isolated away. And then the third layer is just using an iframe, right? Which is just, I feel like you've got that meme with like the
iframe,
the galaxy brain, that is just like, let's just use an iframe, guys. And that one it doesn't allow you to do like CSS styling or anything like that, but you can still, of course, click jack it.
Vanilla click jacking, basically.
Yeah, and you mentioned that there are like these pages that you can load up in the UI. This is another component of the extension, and those are extension pages, right?
I forgot to mention it. Sorry.
No, you're good. So extension pages are like the third component of the whole extension that we created. We've got the background script, which is the service worker. You've got the content script, which gets injected into the page, but is in an isolated world. And then you've got this third component, which is the extension pages, and those can be HTML or just pretty much any attribute, or any like file that's attached to the extension.
So an extension is just like a fancy bundle of files. It's a zip with a signature, and there's just a bunch of files. So those files can be HTML files, right? And there are a few uses for it. For example, when you click on an extension icon, there's a little pop-up that goes up there, right? That's just one of the HTML files that's in the extension source. Or if you like right-click it and go to the options page, and that's another HTML file. So those are like two standard pages, but an extension page is just like an HTML file in that origin, and because it's in the extension can open normally, can put it in an iframe or something like that. There are a bit of caveats there, but we'll get to it.
Of course,
foreshadowing this episode.
Okay.
Yeah. So those pages, because they're in the extension's origin, they have like special privileges. They can connect to the HiveMind, the background script, and the service worker, and communicate with it because they're in the extension's origin. And there's some very interesting attack surface there. Okay.
Yeah.
So now that we're done covering the UI stuff, which, to be clear, is the case where malicious UI is injected into an attacker-controlled page by a content script or whatever.
Okay, so we're covering content script attack vectors right now, and the segment of that was injecting into an attacker-controlled page.
Yeah, so there's UI. A second attack scenario is any communication between that page or like an injected script and the content script. And so that can be custom event listeners, which will look like an event listener and then some name that you don't recognize. Or some name that you do recognize, you can still exploit those. So just like event listeners in general, that the sort of content script adds.
And so in this scenario, like typically with post message exploitation, if they're gonna add like an event listener for that, we need a window reference. So how do we get a window reference to these? Oh, it's the same window. So we just send it to ourselves.
So post messages specifically are interesting because you can either have the attack scenario where it's injected into the page and then you can send it to yourself, or you can have the scenario where it's injected into a sort of a legitimate page, and in that case you have like you can send a malicious message. So you have a bit less control over the input, right? Because that message will have like a malicious origin, so they can verify that and like block you.
When you say legitimate page, this would be like more like the traditional post message attack vector structure, right? So
right.
you've got like two tabs open. One is the attacker page. One is the victim page with the extension loaded up and the content script injected into it. And you're sending a message from the attacker page to the legitimate page or the victim page in this scenario. And
I'm getting a bit ahead of myself.
No, is that accurate though? Right?
Yeah,
is that the
right.
accurate
It
structure?
is accurate.
Okay.
Yeah. I'm getting a bit ahead of myself because I was gonna talk about it in a second.
Okay.
So the second attack scenario of injecting into a malicious page is, as we mentioned, post-message listeners or event listeners in general. Because if the content script listens for whatever event on document.body, you can do document.body.dispatch event and some event that you created, right?
Yeah, we have more flexibility there.
Yeah. You just have some functions that you can reach. And you can imagine if it's like, I don't know, a click event or another event that then the content script does something with, like send a message as a result of that to the background script that does something. You can just sort of hijack that logic, basically. You can trigger that action with an event listener. And I've seen in some cases even like taking some input from the event. So you have like the event.detail property, and which is attacker controllable, and taking some input from that and doing stuff.
Is that like a data property, or is it from post message, or does details contain something else?
It's very similar. When you have like a custom event, you can initiate it with something in its detail. So you can have like a string in the details, an object, something like that.
Data passed when initializing the event. I see. Okay, interesting.
Right. So I've seen, and in that case, I actually had to manipulate the extension a bit to get it to listen to those events. But I managed to set up some scenario where it listened to those events, and then I could do some interesting stuff because I triggered that event, then the content script passed that detail to the background script, and it did something with it.
Okay, so we're pivoting even here from your front end scenario, I guess, and then pivoting through the content script over to the background script with these custom events.
That's the closest I'm gonna get to hacking backends.
Yeah, exactly. Well, I mean, that's all you can do, right? And I guess what is the goal in these scenarios? Like, are we trying to get the content script to
it's very hard to define.
Yeah, like are we trying to get? Can we pop XSS in the extension pages, or are we trying to like get
in the case
malicious JS execution in the content script, or what?
That's a great question. Yeah. I forgot to mention that too. So in every scenario, every attack scenario, you can never get JS execution in the actual origin of the extension, right? So you can't actually get it to execute some JS and then use all the APIs that it has. Because in Manifest v3, there's a mandatory CSP that they have to implement that doesn't allow any scripts other than the scripts that came bundled with the extension.
Okay, so no eval, no
eval, nothing.
Yeah. Okay.
In that,
that's bad.
That's bad.
Yeah.
I'm sorry I got a bit too late into extension hacking a bit too late. I missed that, but it's fine.
Yeah, dude, how cool would it have been
there's
if you
still
had just been
plenty of
able
stuff to exploit.
To hijack the whole content script and
Yeah,
have that
it
arbitrary
must have
communication with the
been
backend.
messy.
Yeah.
So you can't do that, but it's very possible to say the extension adds or I don't know, somehow does something insecure. You can maybe theoretically get it to execute attacker controlled scripts in legitimate pages, right? Because there's nothing in the inherent structure that prevents that from happening.
In the pages of the website. Okay, I see. So legitimate page is the page of the victim website that you would be attacking, right? Okay.
Yeah.
And so like let's say they're listening for a post message, they're not doing an origin check, and then they're concatenating a script to the DOM or whatever with that data, then that would be a scenario where we're attacking the legitimate page via the content script.
Right.
Nice.
So that's kind of not really what we're. I guess it is possible to. In every one of the attack scenarios that we're gonna mention, I think it's theoretically possible to get that to happen somehow.
Okay.
And you can, like in the best case scenario or worst case scenario, however you want to look at it, you can get universal XSS out of that.
Yeah.
Which is very bad.
That's very bad. That is not good.
If I have like an extension that millions of people installed and like people can just read their emails, and that's bad.
That is very bad indeed. Okay, so the holy grail in this sort of scenario for extension hacking is sort of this universal XSS scenario.
Yeah. So we're done covering what happens when a content script is injected into a malicious page. Now let's talk about what happens when it's injected into a normal page, a legitimate page.
Okay.
So that case is very interesting because you have like a bit less input as the attacker, but you have many more sinks or like much more potential for stuff to go wrong if you get input somewhere. Because the content script is injected into a normal page, and the content script has like access to all of the DOM APIs, like we mentioned. So if it does like document.write or something, you can just XSS the legitimate page, right? Which if that page is every page, then a universal XSS, like we just mentioned.
Yeah.
So when you have a legitimate page, the things to look out for is one, are there any post message listeners? If not, can you get it to add a post message listener in some specific scenario?
That's a great point, right? Like oftentimes what we'll do is we'll look at, we'll load up a page and we'll look at whether the post message listeners are there.
I do
or
that
not.
way too much. Yeah.
But I think there's a lot of scenarios where you need to click a button on that page for that listener to be registered, and then something happens. And that's where I've been seeing a lot of post message bugs lately.
Yeah. So you can have that, or sort of the attack surface here, in the case of a content script injected into a regular page, is very similar to just the normal attack surface that you would have when you try to hack the legitimate page directly. Because the content script can like have, take URL parameters, stuff like that, because it has access to the location. So it's pretty much the same. You can have like... You have the same sort of what I call universal input sources, which is like location data, post message data, stuff like that.
Hash,
you could, of course,
that sort of thing. Okay, gotcha.
You could, of course, have like target specific input sources, depending on the functionality of the extension. But in general, that scenario is very similar to the scenario of just trying to hack a page directly.
Yeah.
And
you can imagine just normal hacking. Yeah. Okay, gotcha.
You can imagine that if an extension is very big, suddenly that adds a ton of attack surface to every page the victim has. Like every page in existence, basically, that the victim can open, which is a little scary.
Yeah.
So if you have a lot of extensions installed, that's something to worry about.
It's risky, man. A lot of stuff is getting injected into every single page. It's kind of, I guess it makes a lot of sense that they needed to do this isolated world thing too, because there's just going to be so much collision across extensions and stuff like that as well if they were sharing the same
That's
JS
also
environment.
a reason they do that,
Yeah. Okay, so that makes sense. On the legitimate, when it's getting injected into the legitimate page, we're just mostly looking at the same sources and sinks and just considering these content scripts as like a JS file included on the page.
Right. You can totally abstract that away. Yeah.
So this is a question that I had then. So the legitimate page one is, less exciting. Like you said, it's more exciting when you can get the execution to actually trigger on an attacker controlled page. So the question then becomes, how do we get the extension to trigger on an attacker controlled page? And I know that this is defined in the manifest file. I'll go ahead and share my screen again so you guys can see what I'm talking about from Spacer Coon's nice article where there's a graphic for this. But I know that there's an environment where you can define essentially the matches array, which defines a pattern of sorts that this extension will run on when it matches the current path, the current location. And I was looking at this and I was like, please God, let it be a regex. Because if it's a regex, you know what I'm thinking, right? Matan, the dots. Yeah. The dots would be amazing, but it's not a regex. It's an actual, it's like a custom syntax, right? That makes it a little bit more difficult to get it to execute in an environment where it wasn't intended to execute. So have you poked around on that at all? Like, is there have you seen any weird tricks that might result in an attacker's page getting able to run the content scripts or interact with the content scripts?
Yeah, when it comes to that, usually it's either like intended, and you'll see like all URLs in the matches pattern, like the literal string all URLs.
Okay, that's like a special case.
Yeah, that's a special case with like brackets around it. Or you will have like a page and a site that they inject into, and you can access that site, and now it basically becomes an attacker control site.
Ah, interesting.
Yeah, and then the chain just gets way too long, you know. When then you're trying to pivot and stuff like that.
If you, because I know that there's like, wow, interesting stuff, because then I know that some of these extensions also have a way for you to access cookie storage that are associated with other entities, right? So if there's a way that you can get an XSS on one of these trusted domains and then interact with the extension. Do you know what I'm talking about, or do you not know what I'm talking about?
Yeah, you mean like getting an XSS there, then interacting with the extension to somehow leak data for other sites?
You can do that, but I want to say that there's specifically, so scroll down to on the Space Raccoon article, scroll down to just go ahead and search for permissions as a string, right? Yeah. And it says, in addition, the extension has permissions to access the cookies of multiple other origins, and then it shows like permissions, cookies. And then he describes in this scenario how the application actually defines an on-message listener that allows him to grab cookies for any specific origin. And so let's say there was a similar functionality with that. You can take the XSS that you have in a some obscure subdomain of whatever.
Or just like as intended functionality, having the extension inject into a legitimate page. Or an attacker control page, sorry.
Right. And then wow, that is some very interesting attack scenarios then, because this becomes a really impactful way to escalate XSSs in obscure subdomains if there's like a star.site.com or whatever in the matches for the manifest.json, and now that's become an attacker controlled page via the XSS, and you can interact with the extension to do bad things. Am I on track with that?
Yeah. So I'm looking at the like different conditions for whether to inject a content script or not. So actually it's important to note that currently we're talking just about the manifest file, right? But that's not the only way you can inject content scripts. You can have just the code in the service worker, just go like Chrome tabs, just select a bunch of tabs and add the content script to them manually.
Interesting. So you've got to read the whole service worker code base as well to make sure they're not dynamically doing that. I
think it's actually might be a bit of a common pattern, because you can just go Chrome tabs query and then query for a certain thing. So say they have like query for a certain URL or something like that. And then
is that a query selector?
No, it's just a query. I wish it was a query selector somehow.
Chrome tabs query, and then what are you passing into it? Are you searching for a URL?
Some object with a bunch of options. I'm not sure what the syntax exactly is, but you can query by URL.
Tabs query. Oh, you can query by URL. Yeah. Okay, interesting.
So that's just like another scenario where you can maybe get a content script injected into your page.
Oh yeah, active, true, last focus window. That's how you get access to the currently active tab. Interesting. Okay, I'm getting a little nerd sniped here.
Yeah.
Wow. Okay. sorry, guys. All right, let's get back to it. But I definitely want to look into that a little bit more. I didn't get a chance to fully investigate that before the show, but that's definitely something that is very interesting, because if it's dynamically injecting those content scripts, and the logic is a little bit less defined, because I think in this scenario, like the match patterns for the manifest.json file make it pretty impossible for you to make a mistake. There's not like a lot of
they're very strict.
Yeah, it's pretty well defined. But if they're just using something like, chrome.tabs query or whatever, then it can be defined user logic, and they could be using regex. They could be, checking the page for a specific class, the existence of a specific class, and then injecting right into that. And so all you need to do is on your attacker controlled page, just build out that div, that has a specific class, and then boom, now the extension is in your page, and you have the ability to mess with it, like we talked about before.
Yeah, and
very cool.
I mean, in some extensions, I've seen like very long manifest files that have a whole bunch of pages in there, or URLs in there. So I'm sure in those cases you can find like one really old site and just access it easily. But yeah, that's interesting in the case you want to look at the attack surface of having the content script injected into a malicious page. And we've covered that. We've covered having the extension injected into a normal page. And I should mention that the attack scenarios that we covered in both of these examples are only the sort of more general ones. Extensions are very flexible. You can have some dumb logic that they have there. As you mentioned, like getting cookies, just like some post messages now that gets cookies or something like that. It's possible.
That, dude. I love it. It's so good. So that makes a lot of sense for the content scripts attacks, and we've got two other sections here: attacking extension pages and attacking service workers. Where you want to go next?
Yeah. Let's go with extension pages. Okay. Right.
Hold on. Let me refresh my memory. So extension pages, those are the things that you define that are just kind of like static assets on the page or on the extension, right? And they use the Chrome extension / extension ID, which is going to be the same for everyone, right? The extension ID. Okay, cool. So that we can craft, but there are some limitations on how you can interact with those extension pages.
I think there might be a bit of a mitigation there. I'm not sure. I mean, I haven't looked too deep into it, and I'm not sure which context it's sort of implemented in, but there's some scenario where the Chrome extension URL will have like a unique ID in it that you can't guess. But I haven't actually encountered it. Just know that it's possible somehow. I'm not sure.
Very cool.
Yeah. So extension pages, you can sort of look at them as regular pages with a very strict CSP that have a bunch of like extra permissions or features, because they can communicate with the background script. So that can be like another sort of way to pivot, You can go either through the content script or through an extension page.
Oh, interesting. Okay.
Yeah. So I'm going to give the example. First of all, the extension pages by default, they're not going to be accessible from a regular website. And what I mean by that is you can't open them with window.open. You can't iframe them. You can't do anything with them. You can't even navigate to them, like with location equals.
Like you can't even take your current page and kill your own reference and execution wow, okay.
No.
It's like Coop on steroids there. It's like never get a reference. They can't even open this page. Okay.
Right.
Solid. I see you Chrome developers.
So if that's a feature that the extension developers need, what they can do is sort of whitelist that specific HTML file of a specific page, or they can have like a pattern. So what I'm talking about is there's a key in the manifest file, web accessible resources. maybe there's also a dynamic way to define that. I'm not sure. Just not like as a static thing. But you have the web accessible resources key. And that has a bunch of patterns where you can define which files included in the zip file of the extension are gonna be accessible by regular websites. And you can also define which website that is. So it can be the all websites, or it can be like a specific origin that you trust. And now that set of websites will be able to open those sites, iframe them if they don't have any extra restrictions and stuff like that. Now, what's very interesting is, and now we're getting to the bug that was in the MetaMask extension. When you have one page that is web accessible and you sort of iframe it or open it or something like that, and so you have like page A that is web accessible and page B that isn't web accessible, if you can somehow open page A, either in an iframe or in a new tab, and make it redirect to page B, then you can access page B.
Really? So you can get a reference to it?
Yeah, you can get a reference to it. You can put it in an iframe.
Wow.
Anything.
Okay. So let's say we have an extension page that's like redirect.html or whatever, and it takes, and that one is web accessible.
And we don't even have to be theoretically. We can actually talk about the MetaMask bug.
Okay.
Because
perfect.
the details are public.
Sure.
And there's a BBRE video about it if you want to learn more.
Nice.
But,
we'll link that.
So the MetaMask had a specific page that was, I think, like a phishing warning. And it displayed like a whole bunch of text and then a link. And the thing that it linked to was like the value of some URL parameter. So that's a page that they had that was actually web accessible by any origin.
Oh, wow. So this is like perfectly the scenario that we were...
Yeah,
okay.
right.
Solid.
And they had another page that was like the notification page, it was called, but basically it allowed you to click accept transaction, right? The most sensitive click checking you can ever have. So the attack scenario was basically you open that in a attacker control page, you open that phishing notification, phishing warning page with like, and you put in the URL parameter, the URL of the very sensitive page that we definitely don't want to get click checked.
Yeah.
Now you make the victim click on the link that appears inside the phishing warning page, and now that page redirects itself to the page that isn't normally web accessible, but because it just got redirected from a page that is web accessible, you can now click check it. And that's what happens, and they got like 120K.
That's
good for
such
them.
a crazy simple exploit too, man. Oh my gosh. I love how they weaponized the phishing notification, the phishing warning page. They're like, don't get phished. Okay, cool. Now click here. Click the click the big red button. That definitely isn't the accept transaction button.
Thing is, I've looked at that exact same page, but just like a different iteration of it. I think they changed it because of this bug. So it's sad that I was late to that too.
Sad, man, sad. That's how the game works sometimes, though. So,
So there's another trick that I wasn't sure if I was gonna disclose. I can see you smiling there.
Yes, I'm excited. I'm glad you decided to.
Yeah.
Oh, are you gonna disclose it, or you're not gonna disclose it?
Specifically because I don't think that's like very exploitable in the program that I like to hack the extension of. Gonna keep it pretty vague. So I don't mind sharing it. But
sweet.
I don't think it's intended. Maybe. I hope Chrome doesn't get mad at me for disclosing this, but you can get a reference. This isn't like an iframe reference, but just like a reference to a window of a page that isn't normally web accessible. If you can somehow create a scenario where the victim navigates to that page, right? And then in the same tab, maybe after a few navigations, navigates to an attacker controlled page. The reason is because if you have an attacker controlled page and somewhere back in the history of that same tab, you have a non-accessible page, you can do history.back and then just go a bunch of steps until you reach that page, and it will actually let you go back to it.
I'm a little bit fuzzy on how history.back works. So if I run history.back, I don't maintain my JS execution.
I should clarify that a little bit. And actually, you can get a pretty good understanding of it because you interact with that concept all the time. The little arrows that you have in the URL bar, that just goes back one history step and forward one history step. So you can imitate that with JavaScript, basically. And the attack scenario that I'm talking about here is you have a victim somehow land in the non-accessible page, okay? Whether they right-clicked the extensions and went to options or something like that, or copy-pasted the URL.
Here's a scenario, okay? So in our Save My JPEGs or whatever extension that we're talking about, it's kind of like Pinterest where you have a specific image you want to save, you click save or whatever, and it goes to, maybe it's displayed, all of your saved pictures are displayed in an extension page, right? So you click the URL at the top, you say, let's look at my...
and it links like to the profile of the photographer or something like that.
Exactly, and it links back to the page from which you yoinked the image, right? So then you're on that extension page, you click the image, it takes you to the page where you saved it from. Right? And
now it's in the same history.
Yeah. So then how do we get a reference to that other page?
From the page that you had, okay?
Yeah.
This is where it gets a little tricky. But I like those sorts of scenarios with opens and opener and stuff like that. So from that page that has the non-accessible page in the history, you open an attacker controlled page.
Okay.
Right? So or same origin page, because it's in the origin of the attacker. So you open a malicious page, and now from that page, so you have like the page with the fancy history, with the non-accessible page, and you open a malicious page, right? Now you have to have some way of making that page that you just opened the opener of the page with the history, so that it has the ability to navigate it and stuff, okay? So in order to do that, you can just have the first window have some name, like A, and then from the second page, you go like window.open, empty string, comma A, right? And that will just make it, it will both give you a window reference and it will make you the opener of that page. Now, what you do, we don't know how many steps back in the history the extension page was. Right? But what you can do, I think, I haven't actually tested it, but it sounds like a valid attack. Extension pages are served locally, right? They're files on your computer, which means the response for them is gonna be very fast, as opposed to any other page. So what you can do...
Interesting.
Yeah. What you can do is, from the page that you... You have the page with the history, and you have this page where you have persistent JS execution because it doesn't get navigated or anything. From that page, you trigger like history.back in the original page, and you measure how long it takes to navigate. And by that I mean how long it takes for that window to become cross-origin.
So obviously if it was directly in our scenario from the save JPEGs window, you can go ahead and
just go one step.
Go one step back, right? But say there was a sequence of steps going backwards.
Which is a bit more general.
Right. But if it was same origin, you could just do check and see if you have access to the DOM, check and see if you have access to the DOM. Oh, I don't have access to the DOM. That's the extension page, right? So if it was direct, attacker control website, attacker control website, attacker control website.
Right, yeah.
Chrome extension page, right? And so, but if there was some sort of middleman there, some sort of middleman that's not your attacker controlled page, then can you still do history.back from that because it's your opener?
What I'm trying to do is like, from the page where you have persistent execution, you go history.back and measure the delay. If it's like over 30 milliseconds or something like that, or 50, I don't know how long. Then you're like, oh, this isn't the page I wanted. So you navigate it with dot location, which you can do because we made it the opener. That's why we did that. You do dot location and navigate it to an attacker controlled page. Yeah. And now you can do window.back right and specify 2 steps. You can specify how many steps you want to take.
Yeah, with the offsets and everything. Okay.
Yeah. And now you skip back, right? And then you check that page again, see how long it takes to load. If it's not it, you navigate back and you go back 2 steps. You do that until you get to the extension page. Yeah.
So even if there's a middleman, even if there's like a page that is not same origin with the attacker's origin, that is in between the attacker's origin and the extension page, you can still have a methodical approach to stepping back through the history and getting a reference to that other extension page.
Yeah.
Is that right?
So one way to verify if you landed on the extension page is to see like the delay, as we mentioned. And the way you measure the delay is you sort of loop trying to access some same origin attribute like location.href, property. And as soon as you get an error, you stop the counter, the timer. So now you know how long it took to become cross origin after you started the navigation. In this case, window.back. History.back. I haven't tried this sort of combination of cross-origin timing with history.back. I think it will work though.
Yeah, it seems
because
reasonable.
It's a navigation anyways.
Yeah.
So you can identify it via timing, or if you know, for example, that the extension page will have 7 iframes, you can check frames.length to see
use traditional cross-site leak sort of techniques to do that.
So now we have a window reference, either because it was accessible or because we used the weird trick that
we lost you. Move forward a little bit. The microphone, I can't hear you on the microphone anyway. Okay, there you go.
So we have a reference to the non-accessible if you're not determined.
Sure. If you're not determined.
Extension page. Right. Now that you have a reference, you can attack it sort of as a normal page that has a very strict CSP. So the default CSP doesn't mention styles anywhere. So if you can make it somehow inject HTML, you can inject a style and try to do stuff with that. Somehow try to.
The CSP is going to be strict though, right? Yeah. So is that a strict CSP that's just for script execution?
Just for scripts, basically.
Okay, so we can still include external style sheets and maybe do let
me get
sequential
the
import chaining. Yeah, I wonder. Let's check into that really quick to see if we can do sequential import chaining, because then you could. I guess even without sequential import chaining, now with some of the research that came out recently, there's ways to do to leak the actual contents of the.
Who was that by? I don't recall.
I'm drawing a blank on it right now, but man, that research was stunning.
It was like by the guy from PS Paul. Right,
yeah, PS Paul.
Twitter.
Yeah, dude.
Great researcher. Gosh. I liked his like mutation XSS stuff too. It was very interesting.
This CSS, I'll link this. I'm just going to drop it into the doc now so we don't forget. But
wow,
this research with just the scroll bar and just a super in-depth understanding of keyframes and animations and stuff like that. Just absolutely,
it was insane. I still don't understand it, honestly. I tried reading it like pretty late in the evening on my phone and I gave up, tried the next day. I have somewhat of an understanding of it, but man.
I consider CSS injection like one of my things that I really enjoy and I like am pretty decent at. And that just absolutely blew my mind. And I still don't have a full understanding of it. I think for me where the mismatch occurs is like, I don't understand these keyframes and transform and these animations well enough when combined with variables inside of CSS.
And they got like really deep into a bunch of like
Yeah, it's
just tricks and hacks and
Yeah, but it is amazing to see that it's possible to leak text nodes with CSS without sequential import chaining. That's revolutionary. That is a massive dub.
Yeah,
for sure.
So, anyways, the once you have the window reference, the rest is like up to you. It's not, there isn't like a very defined way to go about exploiting it, because all of the like eval location, all of the normal things are not gonna be viable here because of the CSP that we mentioned.
So just talking about that CSP value again, the default value for that is script source self, object source self. Yeah. So that is going to be, and then there's a minimum. The minimum content security policy for this is script source self, WASM unsafe eval, and object source self. So that's, that's pretty intense, but it doesn't, like you said, it doesn't require that you have some restrictions around CSS. So we can still read on these pages via CSS injection.
Right.
Yeah.
And I mean, if that page somehow, like if it's an options page, right? And it, I don't know, gets a post message that changes the option or something like that, you can get creative there. URL parameters. Though I'm not sure if you can specify URL parameters because unless it's web accessible though. Yeah.
Yeah. Oh, I wonder if you can change the hash because that doesn't trigger a refresh, right? If you know the path, then you should be able to do, but then
maybe.
I think you should be able to because that doesn't count as a navigation.
Yeah, right.
That's something we need we need to test.
And you're the opener of the page in this scenario that we described. So the attack scenarios for the extension pages are like one, communication with the service worker, right? Sort of the same thing that we had in the content script. Two, when you're talking about DOM stuff, HTML injection, exfiltration of stuff with CSS injection, and click checking if it's web accessible, or if you can get it a web accessible page to redirect, which I love the fact that that's possible.
Yeah, that's pretty great. So if it's the thing that's going to make it really interesting is if it's web accessible, right? There are some weird scenarios where we can make it web accessible via this history.back thing that hopefully Chrome won't patch because you disclosed it, and some other flows, right? If we can get a page to redirect to it, but yeah, and then there's also just sort of the traditional HTML, injection sinks in this scenario where, like, for example, on our save the JPEGs extension, right? Save the JPEGs. It sounds like a social justice cry.
That's a good cause, yeah.
Save the JPEGs.
They're getting too big.
Yeah. They're getting too big. That's good. That's true, man. It's true. 4K. But yeah, if like, for example, in the name of the JPEGs or something like that, or the metadata, there's some attribute that contains HTML and the extension writes that to the DOM of the extension page, then you can trigger HTML injection there and CSS injection and do something also, with that. You just can't trigger XSS.
That's a good example, actually. That's something that I forgot to mention. Not all attacks are gonna require you to have a window reference, right? In that scenario where you can just have like a sort of stored HTML injection there, you can exploit that without the need for all the fancy stuff.
Yeah. So window references are only necessary when we're doing, Postgres message related stuff or trying to affect the hash potentially and that sort of thing. But otherwise, you should be looking at
clicks, maybe.
Clicks, or you could, clicks. But probably the main attack scenario is just going to be to look at the business logic that surrounds that extension page.
Exactly. That's a theme across all of the extension hugging stuff. Extensions are super flexible and pretty locked down by default. So you kind of have to look at how they sort of bent the extension and shaped it for their features. And if you have an account that's connected to the extension somehow, say we have like savemyjpegs.com and the extension sort of uses the cookies of say myjpegs.com to send like authenticated requests, right?
Yeah.
So if you can somehow get it to send a malicious request, like stuff like that, the stuff that isn't standard.
That's interesting. That is interesting because, okay. So this would allow it to send authenticated requests with even when you're on an attacker control.
And that's a very common pattern. I mean, a lot of the big extensions that are like of some company, if they want a way to monetize the extension, they're gonna have to connect it to an account. And when they connect it to an account, there's gonna be some sort of authenticated fetch implementation, right? So if you can somehow get into that, either via, some communication to some extension page, content script, whatever, right? Somehow get into that authenticated fetch.
Yeah, that makes sense.
But it's sort of an example of more custom stuff.
Yeah, well, it maps. I mean, it maps pretty well also onto traditional web hacking, right?
Yeah.
That in a strict CSP environment, and maybe a COOP environment, a little bit extra.
Consult Johan, yeah.
Yeah. So you know what we do when we see CSPs is we talk to Johan. No, that makes a lot of sense. All right, so we've covered extension pages and we've covered.
I'm gonna take like 1 second.
Yeah, let's take a break. We'll come back to it.
Yeah.
Yo, y'all, exciting announcement real quick. We are finally launching the CTBB Podcast swag store. Yeah, that's right. The shirts that Joel and I have been wearing on the pod for the past couple months will finally be available for y'all to purchase at ctbb.show/swag. We gave out quite a few of them at DEF CON, but if you didn't get your hands on one or maybe you want some more, then definitely check out the swag store. Also, if you're a critical thinker on Discord, then check the Discord channel because you'll have a discount code available for you there. Or maybe this is a good opportunity for you to sign up and become a critical thinker if you're not already, because you'll get a great discount on the swag if you do so. All right, cool. I think that's a wrap. Anything else I need to tell you about that? I don't think so. All right, cool. Back to the pod. Let's go. Wait, okay, all right. So now, hitting the ground running, back to attacking service workers.
Yeah.
And the last component of the extensions that we're going to talk about.
We'll go through that part a bit quickly because we just have a lot of interesting stuff to talk about after that.
Sure. Yeah.
But yeah, so when we talk about service workers, they're the sort of crown jewel of the extension. You don't have direct access to it, and you don't have direct access to communicate with it even. So you have to sort of pivot through either a content script or through
extension page.
An extension page. Yeah. And or there's another possibility, which we'll cover in a second.
Uh-oh.
Right. So many caveats in this episode.
Yeah.
I'm sure there's at least one time where I said we're gonna get to that in a second and we never got to it.
Sorry, audience. Sorry about that.
I'm gonna update the comments or something.
Yeah.
How that actually looks like is in the code of the service worker, you're gonna have the sort of equivalent of a message listener for this sort of communication in extensions. It goes like chrome.runtime.connect .onconnect or .onMessage.
Okay.
Those are two separate like listeners, and you call that function with like a callback function as a parameter, and when that service worker gets a message, it will call the onMessage listener. Now, I mentioned onConnect too. What onConnect does is it's sort of a functionality to like from the content script, you can go Chrome runtime connect, and then that will give you back like a message port that you can communicate with the with the extension. And the way that works is you have like the content scripts end of the message port, and I'm not sure message ports are common knowledge, so I'm just gonna cover what that is very quickly. You can imagine it like that can with the string, I like that analogy. I use it in some show and tell.
That's good. I like it.
So you have like the can with the string. So you have like the way it usually works is you have some page, you have two pages communicating, and one of the pages creates that whole channel, it's called, which is a collection of two cans with a string attached. Now it sends a post message to the other page, letting it know that I want to share like a channel with you or a port with you. And it sort of transfers the port. So it just throws one of the cans. And now the original page doesn't have access to the can, but the other page can catch it. And now whenever one of the pages sends a message through their end of the channel, it's going to come out in the other port and vice versa.
Very
right?
cool. It's
So,
like a little,
yeah.
it's like kind of like those Mario little,
Yeah.
you know, you come out of a
Exactly.
little pipe,
Yeah.
you know, that sort of thing. That
Way
makes
too
sense.
many
Okay, cool.
analogies.
Yeah. I'm not, my wife has banned me from using analogies. I need to stop doing it. It's so bad.
Yeah. So in this case, with extensions specifically, they have sort of a native way to do that. So you don't have to do the whole exchange. And that's called connect. So what happens, and I have to prefix that by saying I haven't actually looked at that. Like I've only tested it manually a little, but I haven't actually seen it in action. I've read some code around it though. So the way it works is you, from one of the ends that wants to initiate a connection, either the content script or the
Extension
background
page?
script. Yeah, let's say just for simplicity that in this case the content script wants to initiate a connection with the service worker. So from the content script, you go chrome.runtime.connect, and I think you don't have to pass any options, but you can pass a few configuration options to that function. Now, that's gonna trigger a sort of event in the service worker, trigger all of the callbacks for chrome.runtime.onConnect, right? And now all of those are gonna get a port in like as one of the arguments to the function. And now they can save that port, right? And the return value of the chrome.runtime.connect is in the sort of content script side is gonna be the other end of the channel. Right?
Interesting.
So you just go
then
chrome.runtime.connect, that
Yeah.
automatically creates the two cans, saves one of them as the sort of return value, and the other one it passes to the arguments of the function, of the callback. Yeah.
Okay, so that makes sense. And then the callback function can interact with that can and send messages
and then
through.
both of them can just send messages. It's way
here's-
easier. Yeah.
Here's the question then.
Yeah.
Is it like a normal port where you can say where the content
I think.
the content
wait.
script could pass that port through
Wow, I haven't thought of that. Yeah.
to the client
Huh.
side through the actual actual legitimate page environment?
Let's see, chrome.runtime.connect.
Yeah, I wonder if that's going to happen.
Huh. Yeah, so
Let's investigate that for a second. Hold on. All right, we're back.
Okay,
so
we're back.
we did investigate that because that was going to be crazy if that was possible, because that would lead to a lot of problems. But runtime.port is the type that is returned from the runtime.connect.
yeah, it's
right?
not an actual port.
It's not an actual
Regular
message port.
port. Yeah.
So it's not serializable to pass through as a transferable
Serializable
object.
means that you can send it in a message.
Yeah, and I think post message in particular has like a set of transferable.
Anything
and I think
that
that's not
can
one of
be encoded using or serialized using like a deep clone algorithm. I'm not sure what it's called. Yeah.
So array buffer, message port, writable stream,
Yeah.
audio data, image
You're
bitmap.
exposing some of my tricks, man.
Hey man, that's what you get for coming on the pod.
That's one that I've been exploiting though, all the different types.
Oh,
Not
yeah?
gonna say more than that, yeah.
Oh snap. Okay, all right.
I'm sad to say that on the pod though.
Hey, if it makes you feel any better, we already covered this in episodes in the past, so it's already out there.
Okay.
Yeah. Okay. So we get these. So all right. Let me summarize to this point. When the content script connects to the backend script, also known as the service worker, it does this connect and it gets a port, and it can interact with that port, and the backend also gets a port where it can interact.
So two ways to communicate. One is just sending messages. So just back and forth messages, not post messages, but sort of the equivalent in this case. Or if you want to make things easier, you can have a connection and then just trigger that like on connect, connect/on connect sort of flow, and then you get like a channel where you can just send messages quickly, right?
Sure.
So that's like what the two handlers and functions do, right? Now, what's interesting is you have a separate set of functions named on message external and on connect external, right? Those two are sort of more exposed versions of the same concept. And they allow messages and connections from more sources. So by default, the way it works is on connect and on message are only gonna be like accessible, or you can only communicate with those listeners from either content scripts or
the extension pages. Yeah.
I forgot what we call them. So other than that, you can't like from a malicious site or something connect to it. Now, externally connectable, I'm getting ahead of myself. The external version of those two by default allows other extensions to connect to it.
Interesting. So there's a way for its own content scripts and its own extension pages to communicate with it by default. And then there's also an external connection, which is a different whole flow. And that is that only for other extensions, or is that also for just like any website?
By default, it's only for other extensions.
Okay.
But you can configure that behavior. So the default, there's like a key in the manifest called externally connectable, where you can specify this sort of what other things can connect to it. The default value is for it to be accessible by other extensions, the like external versions of the listeners. But an extension can specify another value. They can specify like all URLs, I think, and just make every URL be allowed to connect. They can specify a few origins that are trusted, right? And then that's like the only scenario. I sort of contradicted this before, but that's the only scenario where you do actually have direct communication with the crown jewel. Right?
Very interesting. Okay, but then that's interesting because, so the only problem is then that we don't have access to that runtime port. That can't be transferred from the content script.
That's a separate thing. Right.
Well, but it is a separate thing. But here's the concept, though: is like if they have externally connectable, right? I imagine that same flow is using that same runtime.port object. If you're using, so that object is instantiatable on the client side. They have that type, right, within the JavaScript execution environment.
If it's externally connectable and you somehow get JS execution in some origin that is in the externally connectable flag or property, then you can just on your own create a port object or send a message, stuff like that, just directly, right? You don't have to go through a content script, through anything, right?
Do we have access to like runtime? How do you do that? Because there's no runtime object, right? That's not on window. Window.runtime.
No, it's Chrome.runtime.
Or
maybe I'm not sure how you actually do that
on the client side. Yeah, that's a little weird.
Well, let me check on some site that does have externally connectable.
Oh, so it exposes the API once
you do have
defined.
Chrome.runtime.
Yeah, so you do, but not on any page. Okay, so we're back.
On the page. Okay, so that's very interesting because there's an API that you didn't know exists on normal pages it isn't even accessible. Like it's not like a function that doesn't return anything. It just doesn't exist.
Right.
But on a page that is in the externally connectable flag, I keep calling it flag, property, whatever.
Yeah.
On some extension, then you have chrome.runtime. The API is exposed, and you can go chrome.runtime.connect, chrome.runtime send message, right?
And you need the extension ID to pass through and then connect to that. And then, that's why when I just popped open my dev console there, because I don't have any extensions that have externally a connectable set for my specific origin that I was on, that's why I didn't see the chrome.runtime.
Yeah.
But if I was on an origin that did have that, then I would have the that Chrome API.
Yeah, and as you mentioned, when it's called from a web page, you need to specify a specific extension ID. Otherwise, it doesn't know which extension you're trying to connect to.
That makes sense. Look at that. Yeah, I do. I went to a page that I have it on, and it's there. That's really interesting.
So there are two ways to get to the external listeners, right? The listeners that have externally in the end. One. You go to an externally connectable, and that's assuming that they have even an externally connectable option in their manifest. You go to an externally connectable page and exploit it, XSS or something like that. Two is if they either don't have that config in there, or they have a config that allows for extensions to connect. Then if the victim installs a malicious browser extension, which is a bit of a worse attack scenario.
Yeah.
Because in that case, I mean, sure, you can make them install a browser extension that has like very little privileges and then escalate to a browser extension that has a lot of privileges. But I don't think users actually check what level of privilege the extension actually asks for.
Yeah.
But I think that's still a valid attack scenario.
Well, the other thing about that is it's the same sort of thing you run across with mobile apps, is that it's very easy to gain access to some mobile apps. And
an extra attacker will just ask them.
Yeah, right? Do like a supply chain attack, or you can buy Chrome extension. This is the thing that, because there's two sides of Justin, right? There's
shady.
There's the hacker Justin, but there's also the business Justin. And the business Justin loves investigating, all sorts of weird businesses and stuff like that. And one of the ones I was just absolutely blown away by is Chrome extensions are freaking cheap, dude. You can buy Chrome extensions for 1 cent per install, like less than 1 cent per install. And so you can,
how much is that for 1 million installs? Like 10K?
It gets cheap, man. Cheap. So it can be very easy to get a hook into a ton of users' browsers via a Chrome extension.
So if you have to argue for that, go for it.
Yeah, they're cheap, dude. But there's not a really great way to monetize them either. That's the problem, is like from the business perspective. But this isn't a business podcast. This is a hacking podcast. So I won't spend too much time on that. Either way, this is really cool, dude. And I didn't expect for that object to not even exist in the JS execution environment if there wasn't a Chrome extension that exposed that.
That's a caveat that I'm happy I just remembered to mention. You can have on connectors external and on message external listeners, not only on service workers, but also on extension pages.
Oh, interesting. Okay.
So extension pages can actually listen for external connections and messages. So from like a malicious extension, you can go and connect to the page.
Oh, I wonder, you wouldn't even need to be in the same, you wouldn't need a window reference or a tab group.
No, you can just connect to it.
Oh, that's interesting. Okay, so that's definitely something that we need to be on top of when we're reading the Chrome extension code is checking whether the on connected on message. Okay.
I'm not sure how you would even like CVSS that, CVSSify it.
Yeah.
The requirement for
another Chrome extension installed.
Yeah, another Chrome extension installed.
Yeah, I mean, it's definitely going to be attack complexity high, I think. Yeah, I think that would be a
maybe
precondition.
develop an extension, have a bunch of people install it, and then be like, it's not a requirement. I already have that, you know?
Joke's on you, Triager. It's in your browser right now.
A month after this episode drops, you hear about a crazy new CTBB extension that Justin just developed.
Install it,
fresh
man.
from the oven.
Okay, cool. So that's a lot of things to look at. One of the things that I wanted to swing back around to was, we covered a lot about the structure. We covered a lot about the attack model surrounding these extensions. How do we get access to the source code that we are talking about reviewing here?
Right.
Yeah.
Also, one little thing before we continue from the structure. I didn't mention one, and it was intentional because I didn't want to get it for it to be too confusing, but extensions can have another component because 3 or 4 wasn't enough. They can have like a native component. So if you have like, and that's what Space Raccoon, that's what he mentioned and goes deep into in his blog, exploiting that specific one. But I think like having an extension is already niche enough, having an extension that has a bug bounty program. So if you had another requirement on top of that, that's like way too niche.
Yeah.
But I think he was able to monetize it at least a little bit.
Yeah. I mean, he found a lot of crazy bugs because there's a big query data set that parses these manifest files.
And it's sort of an intersection of just like JS hacking, which is pretty like rare, and extension knowledge and native knowledge. So you get like very, very specific, and you won't have a lot of competition.
It is something you see with password managers, though. And I think password managers are more likely to have a bug bounty program because of the sensitive nature of the content. There's often a native component and an extension component because of that integration. So definitely some good attack scenarios there.
A lot of the password managers don't pay enough, which makes me very worried as one.
That's very sad. Yeah,
as a person that uses stores basically his whole digital life in a password manager.
Dude. Same.
I wish they paid higher.
Same, dude.
How
same.
amount is.
All right. So how do we get our hands on this code?
Okay, so this code, most of the time you're gonna have just minified code. That's just the reality of the situation. You have to being able to read minified code is a skill that if you don't already have, it's gonna be valuable to get it anyways. It just takes a lot of practice. There isn't a shortcut to that. But in some cases, the extension is gonna be open source or something, and you will be able to get it. But in the normal case, the extension, the sort of file that Chrome downloads from the web store and installs, is called like a CRX file. And you can unzip it with the regular unzip utility. It's sort of like an APK. It's just like a regular zip file with a whole bunch of other metadata on top of it in the beginning of the actual file. So one way to download a Chrome extension is to download the CRX file. You can either go to one of the websites that have the CRX files, but I wouldn't go through a third party. You can install it. You can download the CRX file straight from the web store. If you interact with the API that the web store uses. There's one URL that I wrote in the doc. You can maybe put it in the description or something.
Yeah.
But there's one URL where you can just put the extension ID and you can wget it, and it will just download the extension.
Nice.
Another
and it'll just drop the whole
and
CRX file. Okay, gotcha. That's nice.
There isn't a way to download previous versions, so I'd recommend downloading it once in a while and diffing it or something like that, so you can see the changes. But another thing that you can do, which is I think easier, you can just install the extension normally on your browser. If you don't want to clutter up your browser, you can open a separate browser profile, it's called. And what you can do is just install it, and then Chrome will actually put the source code of it in a specific folder.
Yeah, that's what I normally do. The app data folder for Windows.
So in Windows, it's app data, local Chrome, whatever.
Google Chrome.
But you can just find, you can find the path of it if you go to about : version. It will show you the path of it for for the profile that you're currently using. Because for different profiles that have different extensions installed, you will have different folders. So you will see the profile path, and you just go to that path, and then to the extension folder, extensions folder in there. And then you'll have to go to the extension with the ID. The way you figure out what the extension ID is you go to Manage Extensions, enable Developer Mode, and it will just show it there.
Sure.
Yeah.
Solid. So there's a couple ways to get access to the source code for that. Yeah. And then you're off to the races, finding these
beautify the code, and then you have it.
And so what is live debugging, what does dynamic debugging look like for these?
Yeah, so debugging them is very important, because when you deal with minified source code, it makes your life way easier to actually debug stuff. So there's a bit of setup that you have to do with DevTools. I have the actual steps mentioned here. Let me find it real quick. So you have to go to the DevTools settings, and that's sort of to make debugging available for content scripts. So you go to the DevTools settings, and then like to the little gear at the top right corner when you open DevTools, and then you go to Preferences, and under Sources you have to enable Search in Anonymous and Content Scripts, and that will enable the search to match code that's in content scripts, like the global search, Control-Shift-F. And you also have to remove content scripts from the ignore list. So you go to the ignore list sort of section on the left, and you disable content scripts injected by extensions. Okay.
I'm now checking this now. I actually don't have this set up in mind. So I need to click Preferences, Search. Okay.
Yeah, gotcha. Preferences, and in the ignore list, you have to disable content scripts, and you can disable in the preferences or enable. Yeah, it's the first preference under sources. Yeah. Oh, this one you have to disable.
Yeah, we want that
the content scripts injected by extensions.
Okay. Gotcha. Cool.
Now you're good to debug content scripts. The way you actually do that, you can go to sources. And in the sources, you have a few sections where it normally says page. You can go and you can pick content scripts, and it will show you all the content scripts and their sources. You can put like breakpoints in there. And if you want to evaluate code in the sort of context of the content script, you go to the sort of where you pick the context, which can be like top or some iframe or something like that, and simply pick like the extension that you want to debug.
Nice. Yeah. Okay, that makes it easier.
You'll be inside the isolated world.
In the isolated world.
Infiltrated it. Yeah.
No, that's great. And actually, this tip just really helped me a lot, because definitely I want to have this turned on for when I'm working with extensions. But dude, every single time I freaking open the dev console, for some reason, and I go to sources, it defaults to content scripts.
Oh yeah, me too. It's so annoying.
I hate it, dude, because then I've got to go to page, and it just adds like another couple clicks when I just really should have just opened it up to the thing that I want. So actually, I'm going to go into my preferences and turn off
DevTools.
Yeah.
Ironically, somebody at Google needs to debug DevTools.
Yeah.
Because it's a bit buggy. Like sometimes when I try to see like the HTML code of the page, when I go to sources, it shows like a blank editor, and I have to refresh for it to actually show me the code. Yeah, it's a bit annoying.
It's buggy, man. It's buggy. It's for devs though, so we take what we can get.
So now that you can debug content scripts, you can do that. See all of the breakpoints, like variables, etc. If you want to debug the service worker part, you can go to when the service worker is sort of active, because they sort of get loaded and unloaded when needed. You can go to about : inspect,
Okay.
And then you have a section for service workers in the left. There's a section for extensions too, which inspects like a separate part, but just go to service workers.
Okay. Service workers. Okay.
Yeah, and then you have a whole bunch of stuff. I hope you didn't leak anything important.
Yeah, I might have the video editor guy blur those out so not everybody.
Yeah, I mean it's only extension IDs, but yeah.
yeah. Okay, cool. Well, that makes sense. So we can go in there and click inspect, and then we can debug those service workers, and those are all the components. We've got the service workers, we've got the content scripts, we've got the we've got the extension pages, and I imagine the extension pages, they're just sort of like normal dev tools debugging for those.
So I'm gonna mention that as much as we did talk about the structure and stuff, there are a whole bunch of concepts that we skipped because they aren't as relevant. Like I think they're called background pages or off-screen pages. That's what they're called. A whole bunch of stuff you can look at that in the Chrome docs. They explain stuff pretty well if you want to.
Wow,
now, are we gonna move on from extensions?
Yeah, dude. I think that puts a wrap on the extensions. And I'll tell you what, Matan, this one's we've done a lot of stuff on this one. So actually, I think we'll cut it here for today, and then we'll go and talk about this cookie.
Yeah, we're ending every episode on a cliffhanger.
Dude, we are, man. But actually, what we'll do, listeners, is we'll actually just cut it here for my editor's sake, so I don't overwork them too much, and we'll go record the next episode right away, so we don't lose any momentum here. And we'll have that up the week after that. Okay. So Matan, dude, thanks for the masterclass on like browser extension hacking, dude. The structure, the attack vectors, this is exactly what we need to know to start poking at these. So great work, man.
It was great being here. I always enjoy it as always. And
sweet.
Yeah, thanks for having me.
All right, let's go get that cookie stuff. Let's go. And that's a wrap on this episode of Critical Thinking. Thanks so much for listening. And if you want more critical thinking content, head over to ctbb.show/discord. Join the Discord. There's lots of great conversations and chats going on over there. And if you want to support the show, there's the Discord subscriber tiers, which give you access to masterclasses, AMAs, hackalongs, exclusive scripts, and an exclusive chat channel with us. We'll see you there.